So to pick up that conversation, I just had it on the end there. When you have a double root, it's going to sit on the graph, okay? And they call that a multiplicity of 2, means it happens twice. If you ever have a triple root kind of saddles it like this, okay? It saddles it like this. Sometimes it's hard to spot it, and so that's when a root happens 3 times. Okay, so we're going to kind of talk about solving it and then finding the zeros, and then we're going to sketch a graph based on the characteristics of the graph. So we're going to combine most of what we've done already. We're not going to use any of the long division. That's the only thing we're not going to apply here. All right, so to solve this by factoring, first off, let's factor out the -1 because we don't want our leading coefficient to be positive. So I'm going to divide each of these by -1. Okay. Now we're going to play the game of what multiplies to 16 and adds to -8. So what multiplies to 16 adds to -8. What about -4, -4? -4 times -4, 16. -4 plus -4 is -8. So remember, it's x squared on these spots because we're multiplying x squared times x squared is x to the fourth. It's be x squared minus 4, x squared minus 4. Okay. Notice, remember, x squared minus 4, the difference of two squares. It'll be x plus 2, x minus 2, x plus 2, x minus 2. And so now we're going to set each of those factors equal to 0. Okay, and I'm going to have to cram this in here. X plus 2 equals 0. X minus 2 equals 0. So subtract 2, x equals -2. Add 2, x equals 2. Now notice, just like on the last one, we have some repeating answers here. And I'm doing them on purpose here. I know I'm doing all these, I'm solving each of these, and you could, of course, pause the video if you had to. I was just going through the algebra kind of fast. I set each of these binomials with a variable in it equal to 0. So I get -2 happening twice and 2 happening twice. So what are my zeros? Well, -2 is one of my zeros. And how often does -2 happen? Twice. So -2 with a multiplicity of 2. And I also have 2 happening with a multiplicity of 2 because it happens twice. So both of these happen twice, okay? Now we're going to look at some key characteristics. The y-intercept. Remember, the y-intercept is just the last term. That's not going to help me too much on this because I'm not going to be able to plot 0, -16 on here. Is this even or an odd function? This is an even function, so it's going to have end behavior. It's going to go in the same way. And with a negative leading coefficient, we got a negative leading coefficient. And so what does that mean? That's going to affect our end behavior. Remember, we have an even with a negative leading coefficient. We can go back to the end behavior notes. Even with a negative leading coefficient, remember, even they go in the same direction, and when it's negative, they're both going down. So even they go in the same direction, and when it's negative, they're both going down. So it's going to look kind of like this. Actually look very similar to this, believe it or not. Okay. And so I'm not going to be able to do this graph perfectly. So as x goes to -infinity, this one's going to go down to -infinity. As I go to positive infinity, it's going to be going down to -infinity in both directions, okay? So let's plot some key characteristics from this graph and talk about what it's going to do. I know it's got zeros at -2 and 2, so I'm going to plot those. I know I have a y-intercept at -16, which is way down here. This is going to be a white trash production here. This is not going to be pretty. Okay. Anything else key here? No. Now, we know at the very end, it's going to be going towards -infinity, okay? But what happens here? Does it cross here or does it go back down? And when it has a double root, remember when it has a double root, it touches it and then it goes back down. So actually right here, what's going to happen is it's going to touch the graph and go back down. And it'll go back down here through a certain way. It'll go through that 0, -16. This is a white trash thing, as I said. And then it's going to come back up to hit this 0. But what's going to happen when it comes here? Does it go through it or does it go back down? It's going to go back down because it's a double root. The graph is going to look something like that. Now, this is obviously a rough sketch. Okay, you wouldn't have to do this necessarily. What I'm trying to get you to see is just use the key characteristics of the graph to try to sketch what you can. There's sometimes more going on in the graph than what we can see. And I'm going to need to zoom this out a little bit. But this is, you see, we're getting the idea. This actually isn't bad. Zoom 6. And so this is kind of what we're looking at. You see, it's not bad. And what I want you to, I kind of want you to get the y-intercept, but that's out of the view, so we can't do that. But you see that it hits, it's going down forever to the left, and it hits the negative, hits the 0, comes back down, it goes through the y-intercept, hits the other 0, and then goes back down. That's the big things I want you to see, okay? So we're not, it's all right if you don't get it perfectly, but we're trying to get some, we're trying to put it all together here, okay? So now let's go look at the next one. This one has 4 terms. So how do we factor when we have 4 terms? We'll do factoring by grouping. I'm going to put plus negative. I'm going to rewrite this. X cubed plus 2x squared plus negative 9x minus 18 equals 0. You're going to put parentheses around the first 2, parentheses around the last 2. What does x cubed and 2x squared have in common? X squared. Add 3 x's, took 2 out, so 1's left. 2 x's, took them out, so x plus 2. What is negative 9 and negative 18? Remember, if the leading coefficient is negative, you have to factor that out, so it'd be negative 9. Negative 9 divided by negative 9 is 1. Negative 18 divided by negative 9 is 2. What do these two have in common? They have x plus 2 in common. So x plus 2, and then when I factor that out, what's left over? X squared minus 9. Okay. I notice x squared minus 9 is a difference of 2 squares, so I can factor this further. X plus 3 is minus 3 equals 0. Now I'm going to solve. So x plus 2 equals 0, x plus 3 equals 0, x minus 3 equals 0. So subtract 2, x equals negative 2. Subtract 3, x equals negative 3. Add 3, x equals 3. Okay, so we have 3 solutions. By the way, we would expect to have up to 3 solutions here. Here we're supposed to have 4, but what happened is 2 of them repeat themselves twice. So zeros, what are my zeros? I have negative 2, negative 3, or negative 3, negative 2, and 3, and they each have a multiplicity of 1. So I'm just going to list them, negative 2 and 3. I'll put each root as a multiplicity of 1. So it means it just happened twice. What's the y-intercept? The last term, or the constant, 0, negative 18. Is this one even or odd? Well, the highest power is a 3, so it's odd. So it's degree 3. And it has a positive leading coefficient. Okay, so positive leading coefficient. Okay, I probably should put like degree 3, degree 4. Okay, just so you know. And behavior. So now let's remember it's a positive, an odd positive. So how do odd positives? Well, odds go in different directions. And how do positives work? Okay, so let's go back to that page in the notes. I can find it here. Odd positive. So an odd positive is I go forever to the left. It's going to go down to infinity. They go forever to the right. It's going to go up to infinity. So odd positives go from down on the left, up on the right. It's going to go down on the left and up on the right. Okay, and then if it's negative, it just flip-flops. Okay. Not too bad once you get the hang of it. Now let's graph some key characteristics here. I know the roots are at negative 3, negative 2, and 3. I know I have a y-intercept at 18, which I'm not going to be able to plot on here, but I have a y-intercept down there somewhere. Now, I know as I go forever to the left, it's going down. So on this furthest 0 on the left, I'm going to go down. Now on this one, this has a multiplicity of 1s. What does that mean? It means it actually goes past, it goes through the x-axis. How far? Honestly, I don't know, but I know that it's got to go back through the x-axis to get through here. So I'm just going to go a little above and then underneath, and it's going to hit through the y-intercept and then come back here. And this is not exact. Then it's going to hit this point, and then remember, it's just multiplicity 1, so it goes through, and then for the end behavior, it goes up at the end. This does not look pretty, and that's all right. It's all right if it doesn't look pretty. What I'm wanting you to do is I'm wanting you to be able to apply the concepts, knowing some key characteristics of the graph. Can you visualize what's going on? Can you visualize, given the graph, can you recognize the end behavior, the y-intercept, the zeros, and use those to get an idea of what's going on in this graph, okay? And so, like, I've got a decent idea what that's going on. As bad as that is, I mean, it's still pretty close. So